Okay, so this lesson is on friction. Now, if you just have a look on the PowerPoint that I sent out, you've got these notes on there, but we'll just run through them quickly. So we haven't done anything on friction yet, but for friction, it's just the idea that some surfaces are rougher than others and therefore have greater friction forces. The coefficient of friction, this symbol here, mu, gives a measure of the roughness of the surface. A heavier object will have a greater frictional force as the formula for friction is given here. The friction is less than or equal to mu times R being the reaction. When it's at this maximum value, friction equals mu R. Okay, this is when the object is about to move or is moving. So it reaches its maximum value and is equal to when the object is about to move or is moving, what we call limiting equilibrium. Otherwise, friction is less than mu R. Right, so if you've got an object on a rough surface and an increasing horizontal force is applied, there becomes a point when the particle will start to move. So if you've like a particle like this, if you've got a force pushing it this way, at some point it's going to start to move. This is because friction can only increase to a certain point. This is called the maximum or limiting friction. So friction can increase to a certain point, its maximum. After this point, the object will start moving. Okay? If the applied force exceeds the limit, the block will move. When the block moves, the force of friction will remain constant at its maximum value. Friction will not be larger than is necessary to prevent motion. So, for example, if the force going this way is 10, friction will just match that. So say the maximum friction could be for this one would be 30, it'll just match the force going forward of 10, so friction would just stay at 10 and stop it moving because the friction is too big. If you have a look at this example here, so you've got a force P acting on this object, you've got friction in the opposite way, you've got reaction, and you've got a mass times gravity. There's three situations. So the first situation, when P is less than friction, the frictional force will equal P as these forces balance, and it will be in equilibrium and remain at rest. So if this force here is smaller than friction, it's not going to move. So for say example again, if friction was 30 newtons and P was only 10, it's not going to move, and because P is 10, friction will just match it at 10. When P equals friction, so say if this was 10 and friction's max was 10, it reaches maximum value and it will be in limiting friction or limiting equilibrium and is on the point of moving. If P is greater than friction, there will be a resultant force which will start to accelerate the block. So if P is bigger than friction, so if P is say 50 and friction is only 30, it's going to start moving and they'll be accelerating. Friction will stay its maximum value.